topic design thinking approach for amplifier design. So we are going to consider amplifiers for various applications like audio amplifier, RF amplifiers. So you have to discuss the design thinking approach, all the stages of DT for the design of amplifiers. So consider the parameters such as gain, frequency response and the noise figure. So these parameters should be in optimum range to be used for the low power applications. So we have to amplify the weak signals such as microvolt to millivolt. So in order to amplify those signals, we have to give a good efficiency, good gain and low noise figure. So for these parameters, give the design thinking approach.
So we all know about that design thinking, which is a problem solving approach, and it includes 5 stages: empathy, define, ideate, prototype and testing. So in empathy part, we usually analyze the user's problems and understand their needs. So for that, first we need to consider the basic needs, that why we need the amplifier. So amplifier has been used in various sectors, which includes it has been used by IoT and RF engineers. And for IoT and RF needs, amplifier should be high precise and high efficiency. And it is also used in the audio applications. For audio applications, the amplifier plays a major role in providing the output in a very clarity way. And it is also used in biomedical sector for an ECG and EEG amplifiers. So for all these, we have been using amplifiers. The main users problem should be those amplifiers should be very portable and robust. So for a portable, we need to design a very low power battery, and it should be affordable to gain more consumers.
In design thinking, the second stage is define. The purpose of define stage is converts the user needs and empathy insights into clear and measurable design requirements. The problem statement, for example, in biomedical engineer, users of wearable medical devices, they are struggle with weak ECG signals and comfort issues, limited battery life and some other problems. Defined a problem statement, we designed a low power, low noise amplifier. It converts the microvolt signals into ECG signals into millivolt ECG signals, and it operates at reliable across different body temperature. Success matrix is gain proportional to 60 dB and bandwidth is 0.5 to 40 Hz and power is less than 2 milliwatt.
So the next stage of design thinking is Ideate, which gives multiple ideas to the problem statement. So in amplifier that comes different types, we want to choose based on our application. So first is audio amplifier, which has different types like class A, which is a very basic type, and class B, which is a balanced and more efficient type, and class D, which is portable and have low power. And next is RF amplifier, which is used for LNA instrumentation, and the RF amplifier are more efficient and stable. Also, it is portable. So next is instrumentation, which use differential amplifier. So the differential amplifier and also a class E amplifier. So these are the amplifier types. We can choose what our application needs.
In the prototype stage, we use computer tools like ADC, Cadence, and MATLAB or Spices to check whether the circuit is proper or not. And at first, we check whether the circuit gives a proper signal or a proper strength or proper speed of the signal. And then we see how much unwanted noise or sounds are present in the circuit. And we also check whether the circuit heats up when it is heated. And at last, we design a simple board to check the whole design, and we compare the performance requirements, and if needed, we design a new circuit.
The last is test. The test protocol in real world use are audio device. When testing protocols in real world use are audio device, RF device and last biomedical device. Audio device are used for sound quality, efficiency, heat stability and signal efficiency, and then RF signal device are used for signal strength, noise and power handling, and last biomedical device are used for low internal noise and noise rejection.
Okay, thank you for discussing your ideas on the design thinking approach for the design of amplifiers. So particularly we have given a solution for designing the low noise and also high gain amplifiers for audio and RF applications. So in this, for high efficiency application we can use class AB or class D amplifiers, and also it gives very low noise figure less than 2 dB. So by using this approach we can design in high efficient low noise amplifiers for heart rate sensors. So thank you for discussion.